This is question 11 of the component 3 lower 6 in-class question book. Lidocaine is a local anaesthetic used by a dentist in numb pain. It believes that it blocks the sodium-ion channels in a neuron membrane. Okay, we recognise, we know what a neuron is. We know it's a cell, so we know it's got a membrane, and we know about ion channels. So this is all pretty straightforward. Describe the function of these sodium ion channels. So it's a nice easy start to the question where they go, well, what does this basic thing do? So sodium ion channels, they open to allow sodium ions to rapidly diffuse into the neuron axon. So that's our first mark. So sodium ion channels allow sodium ions to rapidly diffuse into the neuron axon. And what does that normally do? Well, we've gone from resting potential, then the sodium ion channels open, and then that's our action potential. So this is depolarization, allows depolarization of the axon. Or we could describe that the inside becomes negative compared to the outside. Inside, we've got our 2 marks now. Inside becomes negative compared to the outside, or we could say might generate an action potential. Generates action potential. Explain how lidocaine acts as a local anaesthetic. What does it do? It blocks this process. So really we're saying that this won't happen. But it's 4 marks, so we need to break it down step by step. So let's turn this first statement on its head. So sodium ions can no longer enter the axon. Then we presumably the end of this story is there's no action potential. So let's just put this down here. No action potential. So there's 2 of our marks, and those are probably the 2 that you think of first. So sodium can't go in, so there's no depolarization or no action potential. But we need 4 marks, so we need another couple of points here. So what could we put in here? So if no sodium goes in, why wouldn't we get an action potential? Well, we only get an action potential when a threshold is reached. So we can say here that no, so the threshold is not reached. So no action potential. Well, we still need a 4th mark. Well, why does it act as a local anaesthetic? Let's go back to our start, to numb pain. Well, pain is really felt in the brain. How do you feel pain? What sort of neuron are we thinking of? Well, these are sensory neurons that sense pain and send that to the brain, and then you start complaining. So that's the last mark. And if you think about your reflex art, you know about sensory neurons. So there's no action potential along the sensory neuron, or perhaps you might get away with the neuron that's sending the pain message to the brain. Right, something almost as painful as going to the dentist is doing this next calculation, possibly. A frightening amount of information, but we're just given an equation. Alright, okay, we're just given an equation. Calculate the maximum dose what have we got? Maximum allowable dose. This is the maximum allowable dose is 7 per kilogram. Per kilogram. Okay. 7. We don't need to change the number. The units are the same. Okay. Mass of the patient. Mass 60 kilograms. The units are the same. Bit of a gift so far. This divided by 10. Okay. Times by 1 divided by concentration of lidocaine percentage. If the concentration is 2%, can it really be that straightforward? Okay, 7 times by 60 divided by 10 times by 1 divided by 2, 21. And that's the answer. Bit of an anticlimax, that equation. You should really have to work harder for 2 marks, shouldn't you? Part D. The marine cone shell, Conus magnus, releases a chemical which blocks calcium ion channels on the pre-synaptic membrane of the synapse. Okay, and also this can be potential use as an anaesthetic as well. Okay, refer to the presynaptic neuron only, so no postsynaptic stuff or cleft stuff, no mention of clefts, please. Describe and explain. Describe and explain the mechanism which the chemical could work as an anaesthetic. Okay. So it blocks calcium ion channels. So if we block the calcium ion channels, then calcium won't be able to move. Where does it move? It moves from, if we had our presynaptic knob there, there's our synapse, and so we get calcium moving in there. So that's our first. So if we block these, that's not going to happen. So calcium ions do not diffuse into presynaptic neuron. Or the synaptic knob or across the presynaptic membrane. Okay, 3 marks. Okay, well, what will that then prevent? Well, we usually have kind of vesicles containing the neurotransmitter moving and then fusing and releasing the contents. Well, that's the next thing that's not going to happen, because that's the next thing on the list. So this prevents the synaptic vesicles from fusing with the presynaptic membrane. So this prevents synaptic vesicles, or vesicles containing the neurotransmitter, from fusing with the presynaptic membrane. And so then this won't happen, the neurotransmitter won't get released. So prevents neurotransmitter, or ACH possibly, or ACH being released into the synaptic cleft, or from that membrane. And that's our 3 marks. So the knowledge required in there was pretty straightforward. Even the maths was pretty straightforward. Hopefully you got 11.